We invite engineer Marcelo Maia, manager of the project by CHESF, to preside and moderate the lecture of the seminar. Engineer Marcelo Maia is graduated in electrical engineering by the Federal University of Paraíba in 1978. He has a graduate degree at electrical engineering by FA 1978-1980 and has an MGA by the Getúlio Foundation 1997. He's been working in CHESF in the era of transmission planning. From 1979 to 1999, he was an electrolyzer studying new technologies for transmission. At CHESF, he was advisor of the department and superintendent and head of division. He is currently involved in studies of research and development in surge arresters, saturated capacitors, and half-wave transmission. Well, good morning, everybody. To start our seminar. For the first presentation of the strategic project PD from NL, the call 444 from 2008, test of transmission of energy in line of half-wavelength technical studies. The presenter will be Dr. Camilo Machado, Júnior from Eletronorte. Camilo is graduated in electrical engineer by the Brazilian University with a specialization in electric power system by the Federal School of Engineering of Itajuba. He works in the area of planning of the Eletronorte planning system, developing activities of studies of transient electromagnetic system and the planning of electromagnetic system. Camilo, you have 20 minutes, but there is a discussion. 30 minutes.
Good morning, everyone. It is an honor for us to talk about this topic of transmission in half wave, and in such a special moment of having all the experts facing the same challenge. So first of all, I'd like to thank all of you for your presence, especially those coming from such a distance to this event. I'm going to talk on behalf of these other coordinators of the project, engineer Marcelo Maia and Éden from the ENTE company. Our intention is to talk about the main realizations from our research project in the study of a long-distance transmission line in half-wavelength. Our expectation, I'm going to try to speak a little slower because of the simultaneous translation. But our expectation is to present during these 30 minutes, first of all, the motivation, what led ANEL to define this strategic project, and some conditions regarding a transmission project on half wavelength. After that, we are going to talk about the project itself. We are going to define first what are the purposes, the goals of the project, what were our doubts when we started, and the main questions or issues about the technology of half-wavelength transmission. So we can analyze the beginning of the project in comparison to the results we obtained, the main steps that were defined in the project, and finally, the products that we obtained after this research. And this third item, we are going to take advantage to create some motivation points so we can take advantage of this discussion, because we have the presence of all the experts here, and these are issues that we included to motivate a debate on the subject. What's enriching about the seminar is the exchange of information we can have. Just to present the motivation, before I start my presentation, we had consulted APE, which is the Brazilian company responsible for defining the new expansions in Brazil. And the question was, what will be the future long-distance transmission planned? Because we had the CC link, we had the Belo Monte transmission, and the answers we got were these ones. We have the transmission of Tapajós, which is this one, from the Tapajós River. And then we have a study of the interconnection with the Guyana. Here you can see in the map, this is thinking about 2022 in terms of research. So what we have today, effectively, of in APE is this study associated with Tapajós. This is a very updated map of the energy plan for 2030. Especially for those of you who are not familiar with the Brazilian system, just so you have an idea, the main message is that most part of our hydraulic potential to be explored is located on the north or middle west of Brazil, about 70% of all the potential. So looking at that, what is our expectation? Is for us to have long distance or transmission systems in long distance connected from the north of Brazil to the large consumer centers on the northeast of Brazil, links to the southeast and also to the south of Brazil. Here, this also shows the great expansions, about 12,000 or 13,000 of megawatts until 2022, located on the north of Brazil. So in the north of Brazil, we are going to have a large potential to be explored. Just to motivate you, talking about long-distance transmission, what are the conditions so we can have a long-distance transmission system? First of all, we are going to need long transmission lines. This is already defined due to the location of the future power plants. Second of all, transmission of large blocks of energy. We are talking about large plants and large powers to be transmitted. So this is another challenge. Development of alternatives that will reduce the cost of transmission. And this involves a whole system. That's what we call an electrical system, because we have to look at all the variables that are interconnected. So we have to work in different P&D centers, looking for example, alternatives for long-distance transmission, new types of conducting cables to reduce substantially the transmission cost. I remember, this reminds me of a sentence that a researcher from England a long time ago, when he visited Brazil, he said to a professor, a friend of ours, this was more than 30 years ago, when he looked at the size of Brazil, the continental dimensions of Brazil, and he was an expert on transmission lines, he said, and this message is for all the engineers here at UNICAMP, the graduating or undergraduate or graduate students, he said, if you can save one screw on each tower, this will save you a lot of money, because the scale is too big. we are talking everything about 2,000 kilometers of distance. So every small saving results in a lot of savings in the end. So this is how important it is to optimize transmission. Transmission represents 70% of the cost inside of system, and the other 30% in the substation. So third point, alternatives that allow for the regional insertion of energy. This is very important. It is very difficult for you to create a transmission system without thinking about leaving energy at the locations covered. So even a question for you, can you derive any power from half wavelength? I'm going to leave this question for Dr. Cristina so she can answer it. This is a question that many times people ask. Is this a point-to-point transmission? But what if I have a city with 100 megawatts load with potential? Can I cover this? And we're going to see that this is possible, and this will be explored, at least for the first interconnection. In a system in South Africa, when they thought about creating a hybrid system of continuous current and alternate current, they chose to do first the AC, the CA, because you would allow for the regional insertion. Otherwise, the community would not allow for continuous current line to pass in that region, causing impacts. So first, they chose to plant a CA link, and then later to create a one with continuous current. And finally, optimization of the energy transmission lines, because today we work with the unit transmitted power by square meters on the right-of-way. So the right-of-way on the transmission lines, it's very difficult to create new transmission lines, especially in first world countries. Countries like the United States, other countries in Europe, what they do is they do serious compensations, they increase the voltage level because it's very difficult to expand. So they need to take advantage of the energy way to maximize the power. So still talking about optimization, what is a major challenge for transmission in alternate current? Why, when we talk about long distance, a lot of people see this as an obstacle? Voltage control. So you can demand series compensation, the shunt, control of reactive power, and mainly the issue of stability. This is a question that many ask. But is half wavelength, does it have a problem with stability? You have a link when we talk about half wavelength, we're thinking about 2,000 kilometers. Does it behave like a short line? The angles are small. There's no issues with stability. So many arguments that are placed when we are talking about the implementation of continuous current system with talking about stability. For half wavelength, this does not apply, because although the line is very long, there's no issues with stability. Here we take advantage. I think this is interesting. We're going to wait for our colleagues from China to present this, but this was a piece of information that we got recently about the Chinese system, where you would have a large transmission potential for long distance, varying from 1,000 to 3,000 kilometers, with long sources from the consumer centers, interconnection from east to west in the country. So it's there's a high potential for applying the half wavelength technology. This is an information from another huge country, which is India. And our meeting is almost the BRIC meeting, because we have Brazil, Russia, and China. We only need India and South Africa. We'd like to thank the presence of Colombia here as well. But talking about India and their system, take a look at the index that they placed. For voltage level, or the highest voltage levels, they maximize the megawatts by transmitted meter. So here we have the right-of-way, the right of way, how wide it is, and the voltage levels, the capacity of installed, transmitted power. So in India, they go for the 1,200 kV when they can optimize the use of the right of way with 90 megawatts per meter. And finally, we'd like to take advantage of this opportunity. I believe when we're talking about motivation, it's good to remember for us Brazilians, we have large gratitude to Professor Portela, who worked not only in half-wavelength research, but he was a great encourager for the national engineering. He had also valued and looked for the large savings for Brazil, always looking for the best. He was always available to help and research, so he did his work very well, and I'm sure wherever he is, he's very happy with this seminar. So let's continue with his work. Now, talking about the strategic project for a half wavelength, let's give some overall information. The goal is to conduct a study in a line in Brazil, but how can we have 2,200 kilometers of line? Initially, we'd like to say that this project, with a huge interaction with the universities, so we'd like to highlight UNICAMP, the Federal University of Bahia, and the State University of Feira de Santana, and by also companies such as Eletrobras, Eletronorte, CHESF, and ENTE from the TBE group. By this multidisciplinary projects, we have experts in several different fields. In UNICAMP, we counted with the work of Professor Elson, Professor Maria Cristina, our coordinator, who tirelessly has worked really hard, dedicating a lot to this work, always ready to help us, providing us with a lot of information and encouraging the team. Professor Renzo has helped us a lot in the protection area. One of the critical aspects that we talk about that is important to investigate is the issue of protection. Professor Valmir, and by the Federal University of Bahia, Professor Fernando Moreira, and by State University of Feira de Santana, Professor Marco Paz and Professor João Bosco. By representing the transmission companies, so Eletronorte, we have Engineer Aniela, who is here today with us. Engineer Carlos Floriano, he could not be here with us. He's an expert in protection. Moises knows him very well. Vanderlei, who's also an engineer present with us today, an expert for transmission lines. On chef, Gustavo Arruda, also an engineer. Marcelo Maia, the engineer coordinator by CHESF. Osvaldo Regis, an engineer who is also here. He works with transmission lines. Thank you very much. And Paulo Simões, another engineer, and by TBE, Éden, another engineer. So we have a multidisciplinary team, because to talk about half wavelength, we need to talk about protection. Now, the main steps. Here, we're going to talk about for the half wave link. How much time do I have? To form the 2,500 kilometers of lines, how can we form that? So the technicians from the sectors got together, and the idea is to use the north-south interconnection and the southeast-northeast interconnection to form a line. Here we see exactly this line. So leaving Serra da Mesa, Pagurupi, Miracema, Colinas, and going back using north-south 2. And then here we have the interconnection with the southeast-northeast. The idea is for this circuit breaker in blue, the one in Serra da Mesa, would be maneuvered, and we would reach the voltage in Bom Jesus da Lapa. And to do the preparation of this link of 2,600 kilometers, we would remove all the series compensation. It will be bypassed, the shunt compensation as well. and we have to remove the surge arresters. And this was a point that was discussed, because to remove all the surge arresters and prepare the link would take a long time, because we have surge arresters on each phase. This would require a large team to remove simultaneously from all the substations. And we're going to see that ahead this was not necessary. The main steps of the project in a summarized way were, before conducting the study, we would have to do all the simulations, and this was done both using the PSCAD and ATP, the two tools. Yes, we have the expectation of defining a date for the conduction of the study, and this would need to be done in a time where there was no energetic interchange between the north and the south region, so we can conduct the study. We compare the results with the measures and characterizing the specific protection system for the CA link. A question that arises is, in Serra da Mesa, here in Serra da Mesa, the system belongs to Furnas, and there is a relay, a distance relay, to provide protection for this line. And the question is, can this relay provide protection for the whole of the 2,600 kilometers in the line? So this was included in the NL project, so we can characterize a specific system. And the R&D team, this is going to be shown in a study, could show that for this specific condition on the study, with the non-load, made it possible the use of a conventional protection, which is exactly the relay present in Serra da Mesa, to protect all the distance. And this is going to be shown specifically in a paper. I believe Professor Renzo is going to present it. And finally, defining or proposing protecting systems for future CA links, AC links. What are the main issues that arise when we started this research project? First of all, the over-voltage levels in permanent, transient, and dynamic levels, will they be elevated throughout this 2,600 kilometers? Is this going to be concerned? Am I going to damage any equipment, any surge arresters? In case of high over-voltages, what can we do? One of our concerns about the half-wavelength transmission that people talk about is that when you have a fault in one of the phases on a specific point of the distance, you could have very high over voltage on the sun's phases. And some people are concerned about that. So a question, can we solve this? Can our R&D propose an alternative for this, a method that we called, from now on we're going to use this terminology, reduced isolating distance, which is the bypassing of some isolators chains in a specific chain. This is going to be shown. It's one of the results of the products of this research. Another question, throughout these 2,600 kilometers that are formed by similar but not identical lines, does this represent a AC link correctively? Professor Elso is going to show the analysis he conducted comparing an ideal line with the separated parameters. Will the generator or the transformer be at risk? The circuit breakers, the surge arresters. We are also going to demonstrate that in the end it is possible to do the energization of the AC link, and for each of them we have data to prove it. The distance relay in Serra da Mesa will cover the requirements. We already talked about this. Another interesting issue, many people talked about it. Oh, you're not going to be able to do this energization study of 2,600 kilometers, because after the line is energized, even if the overvoltage is small, the circuit breaker is not going to be able to open again, because there's going to be an interruption in the high current. How are these requirements? Professor João Bosco is going to present a very interesting paper because how can we base this on any rules when there is no rules for in terms of circuit breakers or TRTs? So he created a brilliant solution that he's going to present when he compared the real situation where the circuit breaker in Serra da Mesa is subject to, comparing with the half-wavelength solution. And we are going to give this in the results presented. Is it necessary to have a pre-insertion circuit breaker for this? This will also going to be demonstrated. Well, as a product, the idea here, we listed the 24 reports that were produced in this R&D project. And before I show them, I believe it makes no sense to read all of them, so I'm going to give you a summary of what they talk about. Because we have all the reports, they cover the studies in permanent regime of the behavior of the link, all the energizations conducted with fault and without fault throughout the line with the ATP tools and the PSCAD tool. We prepared a report with the data to be provided so we can do the modeling of the system, a protection study for all the link, for single-phase or three-phase faults as well. This is very interesting because in the literature there's not much written about protection in half-wavelength lines. So this was a major gain for the sector for the ANEL strategic project. There are also dynamic studies to see the behavior of the machines. And we also created a special report for the national operating system, because for the ONS to provide a decision or providing the authorization for the conduction of the test, we were required to prepare a report similar to a basic transmission project. And we did our homework. We created this report with all the simulations required, and we delivered it so that a decision could be issued. Just a parenthesis, talking about half-wavelength project research, because throughout this project, not only there is a gain for society in terms of the discussion of the long-distance transmission and the half-wavelength itself, but also the sub-products that we are going to have throughout the project. For example, we are talking about protection for long-distance systems. With 1,000 kV, 1,200 kV, we're talking about protection substations that we could have in 900 kilometers, for example. So this is a huge gain. And we have professionals that are dedicating time for the simulation, such as Professor Renzo. João Lima has also dedicated a lot of time for this. 5 minutes. So these reports, they consolidate everything we talked about over voltages. We had 24 reports. We also did simulations checking the influence of the reduced isolation distance for solving problems. This blue report is the report we created for ONS, so for the national system operator to assess the half-wavelength. So 24 reports in total. Another interesting product. Once the study was not authorized and we agreed to do the simulations using the RTDS from UNICAMP, this was a very important tool. The project could get an exactly the same relay. So using the relay and using RTDS, we did the simulations, so there's nothing more real than that. So this is another gain for the project. We produced technical papers on IPST, talking about electromagnetic transients, the use of conventional relays, which is the solution we have for the half-wavelength, protection scheme for single-phase fault, analysis of recovery voltage for the circuit breakers. I'm going to speed up a little. Also papers on Asia and Pacific, the seminar, Energization of Half Wavelength, and Protection Scheme. Technical papers in 2011 related to the soil influence on the behavior of the half wavelength, analysis of energization. This was also presented in China. So throughout the project, we had the opportunity to interact with different experts from other countries. Also in Canada, this paper was also presented. A paper was also presented on the influence of the soil-dependent soil. Analysis of the energization of the 2,600-kilometer test, also in Canada. In Brazil, we presented on SNPTE. There was a lot of interesting questions in the Brazilian seminar that happened recently, and also in Goiânia, with Professor Elson, we disclosed the analysis of the behavior in the 2,600 kilometers, talking about similar parameters. And the master's dissertation thesis from Professor Elson with the use of similar lines in the representation of an AC link. It's a very interesting paper, work when he did the comparisons. And just to finalize, I would like to mention some topics for the discussion, because when we talk about half wavelength, you have to transmit next to the line power. So it was not done for 500 kV. The study was conducted with 500 kV because this is the line we have, but half wavelength was created to transmit large blocks. We have to think about 1,000 kV, not even 765. We have to think about 1,000 kV. And when we talk about half wavelength, many times people ask, do I need 2 circuits? So just as a teaser to you, it's a 1,000 kV system that is operating in China currently, that have 640 kilometers with a 1,000 kV line. This line is used where the land is flat, and this other one when we have hills. The Chinese engineers optimize projects that were already operating for 1,000 kV lines, and with the optimization of the location of the surge arresters, could get an incredible performance in this line. So in 2.5 years of operation, this line was operating full-time. So people responsible from the project, transmitter engineer, Vanderlei was in China seeing this project. So the performance is excellent. So if we align a line with a very high voltage with an excellent performance using a single pole reconnection, you can have a single circuit. So the use of a 1,000 kV line, we can transmit 4,000 to 6,000 megawatts. So this is the block of energy we want to transmit with half wavelength using the single pole reconnection. And for that, we are going to have talks to experts from China that are dedicating their time to study the single pole reconnection, because you maintain flow in other phases, solving instability and supply of energy problems. The possibility of serving loads throughout the transmission line. In the public hearings, those of you who have the opportunity of participating in public hearings about long-distance transmission, such as the AC link happened, one of the questions that people ask is, how is my city going to benefit for this? Because you're going to build the towers, there's an impact, and what about the energy that is going to stay in the city? So we need to develop a technology that also allows for this possibility. The future possibility of conversion to a conventional AC link system. The half wavelength allows for this possibility. In the future, after 15, 20 years, you can transform it into a conventional AC system. Thank you very much. I got this translation from Russian and Chinese from Google. I hope it's correct. So thank you very much.
Thank you, Camilo, for the presentation and general clarification of the project. We have some time for questions and clarifications. Should anyone wish to? Please say your name and company. João Lima from Marcelo. When you made your presentation, you commented that the national system operator was uncomfortable as not to permit the execution of the tests. I would like to hear some comments as for which were the arguments, the technical arguments, and possibly the economic ones, that the national operator system or the National Electricity Agency presented not to permit the execution of the test. Is this question for me or for both? Well, actually, the meeting we had with the ONS, the National Operator of the system, they thought the project was very interesting and reminded that this proposal had been made in the year of 2008, 5 years ago. In a moment when, let's say, the system could need the lines of the north-south lines of interconnection in two distinct moments when there was no need of energy exchange between the north and the southeast. By then you could even have the three lines out of operation. Well, how's that? Since you have three lines between Cerro da Mesa and Imperatriz, you would use two lines for the test, and you would only have the two systems interconnected by only one line. And when they were to do, let's say, the simulation, in that case, they would do precisely the loss of that line. And that was, even though that was possible, by then, 2008. In 2013, 2012, 2013, we had a meeting. This kind of situation was no longer possible. The system greatly demanded that link, and it was dangerous to have only one line. And there was also the following. At that moment, there had been a series of blackouts in the system. So they said, it's very dangerous because we may, perhaps if we do it and there is any problem, even if it's not the test's fault, it could be included as being this kind of thing, and who would be responsible for that? That was one fact. And the other one was that when you carry out a test like this or any event like this, you need the procedures to perform this test. And the procedures will involve different companies, since the interconnection lines have several companies involved. And also, it's today the market, you buy energy from several agents. There were several agents involved who would have to be consulted, so the moment was not favorable for that. So those were the arguments that they gave us, and we didn't have an argument, a strong argument to counter offer, so we could perform the test. I'd like to add. Marcelo, this is Moisés from Anel. I was going to ask João's the same question as João, but I'm still not satisfied with the answer. Because we know this project started from an idea of my by then boss, Roberto Jedinic, who was enthusiastic with this and wanted to have the strategic project at the end of 2007, 2008. And by then we had more conditions to do it. But I don't think it's impossible to do that. We can't do it when the dams in the northeast have low volume of water, and we know that it takes longer to fill it up in the northeast. But then we know the importance of this project to do it when there is water in the northeast, the flows are smaller. Advanced, told to the society well enough that I've been telling Anel that we are not doing maintenance. We should do it maintenance with even with risk, but warning society. And then if we don't do it, we start having blackouts. I don't agree with this. I think we should talk about this better. And my question is, was this taken to the decision of the committee of the CNS? Because it's the committee that decides those things. I didn't go to all of them. I don't remember that this issue had been the viability of performing a test like this and what time of the year. I don't think that was discussed. I don't think we should just give up and say, oh no, ONS said it, we shouldn't do it, so we're not going to do it. I think we should take this to discussion and should know what is the best time to do it and take it to the deciding committee that's presided by the minister. Well, Moisés, actually, this point is very important. I'd just like to summarize. Regarding ONS, it was clear from the technical point of view, said we are certain that our halfway length R&D team is confident that the test can be performed without having any risk to the system. Overtensions are low, over voltages are low, no asset will be hampered. There are 2 points that after the meeting with ONS, then we went to NAL. 2 things have to be mentioned. One question that was asked about the companies that have assets in those 2,600 kilometers. The question of insurance for the pieces of equipment. Our area of insurance of Eletronorte informed that there is no need of purchasing any additional insurance. You can use the insurance contracts of the companies themselves. And the other thing is precisely the PV. When realizing, when performing the test, there is no risk, if there were any risk of this variable portion at the moment of the test. But the companies were looking for greater confidence to extend that into future cases, and that was complicated. But we are also sure that the tools, the computational tools that we have today, ATP, PES, CCAD, and RTDS, represent reality. They are powerful tools, so we have no doubt about the behavior, about the technology of the half wavelength. The comparison between the measurements of several CA systems with computational simulations have been shown that those tools have reached today so high a technical level that we do have no doubt about the representation of reality. And the important thing is that the message has to be relayed to the furnace colleagues, because there's no asset except for what is in settlements, because everything will be disconnected in the CI link. There is no reactor, no blind capacitor, nothing. And we've shown there are no risk for the settlement message generator. There will be no risk for the rising elevator, for the circuit breaker, and the protection was tested. So from our side, as I'd say, we are ready. At a timely moment, when our energy situation changes, we are still having thermal plants generating energy. I think this can be changed. We are prepared. Just to complete, Moisés, also in Serra da Mesa there are 3 generators, and the study also covered the possibility of having this link with energization of only one of those generators. You would keep the others 2 interconnected to the system. That was also beneficial. Yet, from the point of view of the R&D, of the call, CHESF and ENTE, Eletronorte, and the higher university studies were performed. ANEL was the one that asked for it. So the documents that support the possibility of performing the test will be handed to ANEL. So I believe that will be up to ANEL to take this further ahead and get into an agreement with the national system operator together with the owners of the facilities and set up a date for that. Just to briefly say something, I agree that since we had a denial from NS, we consulted ANEL and continued working. We didn't stop at the part of simulation. I understand that we have to make an effort so that the test is actually performed. As I believe that all of you participants of the seminar will live here with the conviction that there will be no harm to any of the involved assets. So I think that it's very important. The seminar is an important, has as an important aspect to disseminate to spread the conviction that the test would be not harmful to any piece of equipment, and more than that, as we do the simulations, any tests are based on simulation. We are doing the test that would be basically the prototype, since there is no operating half-wavelength system, but to actually ask for the execution of the test to have the half-wavelength as a possibility for transmission in the future expansion of the system has no foundation. It is a problem of Brazil's pressures that are somewhat not connected to the technical error. With the tools we work today, there is no need of a test. The test would be really a prototype, more for a matter of safety or any other reason, but it's not technical. I think that with the results we've presented, we can discuss the isolation distance. We can do tests at a CPL or in the lab. I think some technical aspects, but that can be solved with inside the laboratories in simulators. There's no different thing more than that. I think that we should really have a group of people interested in the entities organized. Interested entities for this alternative to be one of the options for future expansion. Any other? What is this? Tasman. Good morning, everybody. Roberto from CPL. It's a little more technical. I didn't understand, Camilo, when you start. It was shot to disconnect. I understand that the capacitors, the shunts were disconnected. Okay, that you're gonna remove all compensator. But why to turn off the surge arresters? Weissman, the idea of turning off the surge arrestor is because in a CA link that we're gonna plan or install, it always has surge arresters at the sending and receiving ends. There are no midline surge arresters. So somebody could say that the presence of the surge arresters of the existing stations could not properly represent the CA link. So to be more faithful to a CA line, ideally we should remove the surge arresters, but we had a happy surprise that when we said that the over voltages are extremely low, the surge operators don't even get to operate, and that greatly simplified the preparation of CA link, because this is a critical factor to remove at the same time all surge arresters from all substations would take too long for the preparation of CA link. Unfortunately, it was demonstrated that the over voltages are so low that they have no need to exist in the line. Only the surge arresters, and that would greatly simplify the test. But it's to be, in brief, it's to be faithful in the CA link half-wavelength. There are no surge arresters in the middle of the line, only the ends. Cannot hear the question. Sorry. If I'm not mistaken, at the time that those studies started, at the time of by the time of the CPTA, for the deep protection of atmospheric discharges, I do not know if the surge arresters would be necessary along the line for protection against atmospheric discharges. Weissman, when we thought. One thing is for the test. For the test, we don't have it. You don't need it. But let's think about a half-wavelength transmission. I'd say the way is to build a line with a 1000 kV line, using all resources to have a performance as satisfactory as it is in China. 0 disconnections. Then, okay, what are the resources you have? Positioning of the surge arrestor cables, use of surge arresting cables itself in parallel to the isolator chains, because the cost of the surge arrestors is dropping a lot, so it's economically active to have surge arrestors today to prevent disconnection by indirect discharge. And thirdly, to use an excellent grounding system. In China's case, the resistance of the foot of the tower, the repulse resistance, was 7 ohms. Very low. So you practically do not have backflash over, you don't have indirect discharge. So it has excellent performance. And for that, and this is one of the resources. So in response to your question, Vasman, actually the use of surge arrestors can be something additional if you want to have an even greater reduction of the number of exits of land by atmospheric discharges. But from the point of view of energy, there is no need.
This is Qingming Li from North China Electric Power University of China, Beijing City. Okay. So thanks a lot to Camilo for your very good presentations, for the technical reports. You know, from this I have realized the Brazilian researchers have done very good research on half-wave, transmission technology. But at the moment there's no on-site project, so far. All the results obtained based on, simulations. We will based on these results to make a decision to push ahead this technology. This point, my point is how to guarantee the reliability of the simulation, because there's difference, there, compared with the reality. How to guarantee the reliability of simulations? Yeah, that's my question. Thanks.
Okay, maybe can I answer in English? Or okay, thank you. Okay, it's a very good question, but we made all the simulations by using the ATP, the PS card, and also we compare with the RTDS. And in Brazil, we have many papers where we compare the measured results with the computation. And you can see that our modeling is properly, because we consider all modeling in distributed parameters in the line. We model the generators and the power transformers with saturation curves. So we included all details in the simulation. It's very important that we consider everything to have a very reliable results. So we understand that because of comparison for other systems, we have no half-wave length system in operation, but we have a 500 kV systems, a very long system in Brazil. We have a very strong network in 500 kV. And these systems, we made all simulations by using the ATP. And when we compare the overvoltage, recovery voltage, in-rush currents with the simulations, we got a very precise results. So we can say that these tools are very reliable. Yes.
Well, time is well beyond the plan, but we thank Camilo and the questions. And let's say that during today and tomorrow, any questions that were not answered now may be clarified during the following presentations. I thank you all. Thank you.